All right, let's jump right in. Today, we're going to tackle one of the hottest problems in industry. And I mean that literally. We're talking about how to clean up exhaust fumes at temperatures that would just melt your standard filters. It's a huge challenge, and it calls for a totally different way of thinking. So let's dive in.
So here's the fundamental question. Picture the exhaust blasting out of a factory or a power plant. It's over 800 degrees Celsius, it's full of soot, and it's packed with toxic gases. How on earth do you filter that? Most materials would just turn into a puddle of goo at those temperatures. This is the kind of extreme problem that needs a radical new solution.
Now, to really appreciate the new solution, we first have to understand why the old way of doing things is, well, frankly, a total nightmare. It's a story of wasted energy, wasted money, and just gigantic, clunky equipment. Check out this conventional process. It is just wildly inefficient. See, your typical filter bags can't handle anything hotter than about 200 degrees Celsius. So first, you have to spend a ton of energy cooling that scorching gas way, way down. Then, once you've filtered out the soot, the next step, the catalytic converter, actually needs the gas to be hot again. So you have to burn more fuel to heat it all the way back up. It's this insane energy roller coaster that costs a fortune to run. So what you end up with is this massive, sprawling system of equipment, just for cooling, then filtering, then reheating. It's an energy hog, it's incredibly expensive, and it takes up a ridiculous amount of space. You just look at it and think, there has got to be a better way, right? Well, there is. And that better way comes from a family of materials that's been with us for centuries, but re-engineered for today's problems. I'm talking about ceramics. Let's see how a high-tech ceramic sponge becomes the hero of our story. Okay, so what exactly are we talking about here? Porous ceramics are pretty much what they sound like. A huge chunk of their volume, often more than 30%, is just empty space. The best way to picture it is like a super rigid sponge, with this incredibly complex maze of tunnels running all through it. And that internal structure, that is the absolute key to everything. You see, that maze allows for a much smarter way to filter things. Instead of just trapping particles on the surface, like a screen door that gets clogged up really fast, these filters use what's called depth filtration. The dirty gas actually flows into the maze, and as it twists and turns, the soot particles get stuck on the walls deep inside. It's way more efficient and can trap unbelievably tiny particles. But trapping soot is only half the story. This is where the technology goes from being just a great filter to being truly revolutionary. It's not just about catching particles, it's about actively destroying the harmful gases at the exact same time. The technical term for these is multifunctional reactors, and it's a perfect description, really. It means one single device is doing two critical jobs at once. It's physically separating out the soot, and it's acting as a chemical reactor to convert nasty pollutants, like nitrogen oxides, into harmless gases. So how do you turn this ceramic sponge into a chemical zapping machine? Well, one super clever method is this urea method. You basically soak the ceramic in a special chemical cocktail. Then you heat it up, which causes a new material to coat the entire internal maze of the filter. After a final, high-temperature bake, that coating transforms into a powerful catalyst with a huge surface area, all of it ready to break down pollutants. And here is the real kicker. This incredibly effective catalytic layer, it makes up less than 3% of the filter's total mass. With just that tiny addition, you've transformed a simple physical filter into a high-powered chemical reactor. And it still works perfectly at those scorching hot temperatures. Of course, this all sounds a little too good to be true, doesn't it? And, well, like with any advanced tech, it's not quite that simple. There's a critical balancing act that engineers have to get just right. This quote just nails the dilemma. You want to clean the gas as thoroughly as possible, but you also need the gas to flow through the filter without too much of a fight. If it takes too much energy to just push the gas through, you lose all the efficiency you were trying to gain in the first place. So here's the trade-off. On one hand, you could add a ton of that catalyst coating to get more chemical reactions. But if you add too much, you start clogging up the pores and the gas can't get through easily. On the other hand, you could make the pores really big and open for easy airflow, but then you don't have enough surface area for the catalyst to do its job properly. Finding that perfect sweet spot, that's the real secret. Okay, so we've covered the theory and the engineering challenges, but how does this technology actually perform out in the wild? Well, let's look at one of the toughest environments you can imagine, inside a heavy-duty diesel engine.
Now, this is so important. These kinds of advanced ceramics are not some fragile lab experiment. They have been workhorses in diesel engines for decades. We're talking about components like these, made of super tough ceramics that have been withstanding incredible pressures and wear for, in some cases, over 1 million miles. So yeah, these materials can absolutely handle the punishment. And here's the payoff. When you combine the particle filter and the catalytic converter into one single unit that actually loves the heat, you get all these amazing benefits. You save a ton of space, you save enormous amounts of energy, and the performance is just spectacular. It can knock out up to 95% of harmful nitrogen oxides, plus basically all of the soot. It's a win, and another win.
So let's just take a step back and think about what this really means. This isn't just a clever new gadget. It's a key piece of a much, much larger puzzle. The puzzle of how we build a cleaner, more efficient industrial world.
We hear the term green manufacturing a lot. Well, this is what it actually looks like. It's about developing technologies that don't force industries to choose between being productive and being clean. These ceramic filters are a perfect example. They let factories meet tough emission standards without destroying their energy efficiency. That makes them a cornerstone technology for a sustainable industrial future. So, I want to leave you with this final thought. We took one of the oldest technologies humanity ever developed, ceramics, basically pottery, and with some brilliant modern engineering, we transformed it into a cutting-edge solution for a huge environmental crisis. It really makes you wonder, doesn't it? What other ancient materials are just sitting there, waiting to be reinvented to solve the problems of tomorrow? Thanks for watching.